Ladies and gentlemen, likers and subscribers, hobbyists, model makers, nerds of all kinds, welcome. I'm the glue and paper guy. This is some scrap. These are actually bits that I made for the Moonliner very, very long ago. And you see, that's that separation problem I was talking about. That's if you're asking something to be load bearing, that's utterly unacceptable. But there's plenty of real estate here for the other purpose. John starts with the wheels and the bogies. And you see he gets into using some side cutters with pins, etc., and we'll cross that bridge. The first thing I think I'm going to do is get the bogies down. So I need the bogies first. There's John's bogies. That's John's. Looks like wheels and bogies on the same page. Put the other stuff aside. While I'm thinking about it, I don't know if I've ever mentioned this in another video. Even LED lights have a real strong ultraviolet line in them, particularly if you push them up to 5500K. You're going to leave your parts laying around for a while, flip them over. Don't let them sit under the lights, you'll fade them. So here we got, that looks like bogie structure there. Spare page, wheels, and that's bogies, because there's the body. This is part of the suspension as well. It's some sort of marvelous arrangement that goes like this that I'd only really put together when I started looking at the kits. Okay, so we got wheels, we got bogies, we got spare pages. So I'm going to start with John and then go to Julius. So Julius goes off screen for the time being. Let's get to John. These circles are guidelines. That's where the wheels will be. So I'm just going to rough these out. I want to have a stick to hold it by as well. And I've got some real estate here, so I'm just going to do this. So as I do each of these parts, I intend to glue them to a piece of paper close to the edge because I try to be efficient with the material. And I then need a handle. That's going to be a handle. So I'll let me just do this and make sure I got plenty of real estate between both of these. Probably doesn't have to be quite so exaggerated, but it's something to pay attention to. And I'm here to tell you, if I'm in a hurry, I'll, chop the L's head off before I realize what I've done. So there's one. We're going to pause button, take the rest of it out so that you guys don't have to struggle with that. Back at you. There's bogies. A couple of thoughts occurred as I went to carving. Why didn't you cut all the parts out on the page at once like they do in those marvelous time-lapse videos of airliners? Well, if you want to streamline a process, stop having to think. I don't want to think about what I did with that loose part. Yes, I did that with the Shrek ears that you saw in the beginning of the video, because I've made Shrek ears before and they're BFO. I have never done this. I am not losing a part, particularly because I have the privilege of doing this and show off for somebody. So I cut them out one at a time and they don't get lost. Each one of them has been gifted with a handle. So if there's some way to manipulate them against this stuff when I glue it down. And actually, when I think about it, using this area would be to advantage. If it depends on how much of it I can get out of it. It's static. There's not going to be any force involved in this. And if I glue this on the other side of this piece of paper, I get a smooth texture, which I'm going to paint black later anyway. I think I'll probably just go and do that. At least with a couple of them. Of course, there's a trap in that as well. So if I'm going to get froggy and do this with these, either I really get jigsaw puzzle, and you see I'm not going to get but maybe 2 of them out of it. Or I have to glue paper to the back of the other one before I cut it out. So, you know, 6 of one, half dozen of the other. But what would happen, that's a very rough texture for this board. So, you know, it's just easier to paint. You can hide your sins on the edges. It'll paint up nice on the back if it's all shiny pretty. So I'm probably just going to do that. I think there's the backs of the bogies are smaller, or the one side of them. I don't want to be backing and fronting. Because it looks like, let's see, whoop, I'm losing them. Let's see. These guys go here, and these guys the front. So yeah, the big ones are the front, and the little ones are the back. So eeny, meeny, miny, something like that. I don't have X-ray eyes. I can't see through paper. Infinitely easier if I just did this. In fact, we need a big mama for this. It's just faster. These are, I want to say these are number 1s and these are number 11s. Number 2s. I think they're 2. The big ones are 2s. And these are actually X-Acto branded, which is getting rarer and rarer. And these are X-Acto branded too. I got a pack of 100 and I've been burning them off like firecrackers ever since. These are number 11s. Change blades early, change blades often. The tip gets doubly dulled. The edge is dulled by the roughness of the paper. And the tip is dulled by the fact that my big ham hands, I didn't even use the big knife, are driving the tip into another surface and systematically rounding off the pointy bit. I'm patient. Just, just 3 cuts is probably what's necessary to get all the way through it. And the first one helps you with the other 2 so that you get a nice clean edge when you're done. Well, I got to make it a little easier. Let me show off. Fairly partly cloudy. These don't matter, so I don't care. So I can just have done with it. Try not to cut the mic wire. Got it. Okay, so at least for my first couple, I've got something I can do right there, and I know my size, so I can not screw around about it. Thought I was throwing parts on the ground for a moment. We need something like, I might be able to get away with more. I might be able to get 3 out of it. Not conveniently. So, fine. PVA, it will skin the tip always. It's just long past habitual. I peel the goo off the minute before I even open it. And you want to focus the glue on, it's obviously you want to glue what you're going to keep. If you don't have any on the edges, so be it. So, I can see through this stuff in a way that you guys probably can't perceive because of the light. All right, fine. We'll just go in there and, where's my spatula? Okay. Depending upon what I get away with here, I may just, what I take away from this one, I'm going to put on the other one. I'm not that obsessive about about the glue, but it's there, so why not use it, right? And keep your fat fingers away from the money side. That is turned near perfect. Okay, there's my handle. I do a lot of that too. You end up, whatever glue you get on your fingers will cure instantly, and you just flick it away if you rub it. I'll guess and say it's the heat of the actual friction. And so I'm working on some big assembly from some, overblown fantasia of a project, and constantly rubbing the glue off my fingers before I touch anything. It makes a big difference. I don't think I got that axle. Easy to fix. Okay, now we got some more on there. Now that's going to ooze probably. So pull from the pretty to the ugly in case it comes to sticking out the sides. You do not want to mess up the part. That's going to take a little bit to cure. Yeah, that's going to be fine. So I'm going to do these other two. And then rig up the others. And we'll show you the result. Then take a look at the other set of bogies and think where we go from there. Some things to remember: we're actually laminating paper. Glue is full of water. Paper has no water. Paper absorbs the water from the glue as the glue cures. This is very flat because these are small, and it's already been done once. Right now, with these two pieces of the bogie, that paper is also is trying to bow up. Hopefully that comes across. And just moments ago, it had actually puckered up and popped out like this. Now that'll all sort of settle out when it's done, and the puckeriness here will probably largely go away. But the point now is we have the main structure of the bogies laminated up so that there's a nice clean side on both sides to take paint. The back side will take black paint, and the edges will get blacked as well. Another thing about this, on the original parts, these marks are here to help you decide where the middle is, because these points are going to receive wheels. John's noted that in his stuff here. You see in this number 4 frame, we're putting pins through the centers of those things. That being the case, we need to know those centers. We don't want lines to remain on the parts. These things will actually be hidden later, but we need to apply some discipline and make sure that those doesn't happen. This guy doesn't leave any ink behind. I will make a score mark on either side of this. To help me decide where the center point is. That's a swag, but it's probably pretty close. And I can't actually do it with a really sharp pencil, which I think I'm about to do. If you pay careful attention to this in the end, these points will probably be hidden by the wheel. And in fact, we are very likely to make hubs to go internal to the wheel to help the construction and to help the wheel actually turn well. No idea they still make these things, but this is my drafting pencil, which I've had since I was in middle school, the age of 12 or 13. That is as close to mathematically correct as is necessary for the purpose. And I think I'll omit the other step. I just don't think it's necessary when I really sit down to... Pencils make ruts in paper. And this paper is somewhat vulnerable because the ink, the glue underneath, that's not as centered as I would have it. But we'll apply a calibrated eyeball. The larger point here, of course, is you got to kind of think ahead. What's this going to look like when it's finished? What are all the steps involved with the part that I'm building? Not always easy. This one's got lots of pretty pictures, so I can make lots of easy guesses in the beginning. I didn't leave myself much mark there, so this is a swag here. Swag, scientific wild ass guess. With that, with these, I just like the pencil mark. I think that helps me. And the idea of these becoming hubs in a connection sandwich with a pin through them is one of those moments where you say, gee, I'm glad I printed 2 sets of these parts right now. When I remembered the scale, and I remember how I printed them, and I have them to hand, it makes a difference. And I end up using those parts to glue these guys together. There's and there's apparently a hub too, so I have to stop and think this through. So I got 2 pieces. There's my back. So this orients to this. And here's my front. And there's a right and left to these things too. So okay, so they go like that. So the highest joint through the chassis is the big pivot. This joint, and the ends. So since I have the stylus in my hand, it'd be a good idea to mark them right now. Again, looking ahead. It's going to take a while for this to cure. No reason to beat myself up about cutting it right now. So I'm going to mark it right now. And the centers in these are so closely marked already. That's just flat convenience. Do not have to work at it. I'm not pressing all the way through. I'm not trying to cut a hole right now. I'm going to let the pin do that later so that its diameter is correct for the purpose. You don't want these things loosey-goosey. And they become that way very quickly because the pin is almost frictionless against the cardboard. But, less is more right now. Okay. So there's those. They're going to have to cure for a minute. It's now time to think about the bogies on the other kit. Here's Julius's paper replica pattern. We're going to make the bogies for it. We'll focus on the bogies and then wheels separate and distinct. So off screen I have the images that are on paper replica blown up so I can actually read them. And the part numbers are referenced. The pivots that actually hold the wheels are number 50. So I got 150, 250, 350, 450. Those are the ends. There should be a 51 here. And its matching number is a 51. So there's 151, there's 251. These pieces here are all part, they're the knuckles that hold the wheels. 50, 50, 50, 50, 51. Okay, so now we have the knuckles that hold the wheels. And then we have the tubes. I'm going to riff on tubes. There's a lot here. 40. 40, 44, 45, they're twinned. 42 is the other tube. 42. 42. 42, of course, being the answer to life, the universe, and everything. Now, this is all wheels. The wheels will wait. This is a typical score and go problem. It's also a small cylinder problem. I am not a mathematician. I do know some dumb stuff. Circle calculations can be accurately done by simply going on the internet and finding a calculator that works well for you. What if I wanted to substitute these for dowel, or for straws, or for evergreen styrene tubing? Sure would simplify the build. So, Mr. Pointer, there is a relationship between the circumference of a circle and the diameter and the radius. Pi r squared. No, they're not the round. If I measure from here to here, I know the circumference of a circle. I know that has to be the circumference because it's expected that this edge will mate to this edge of every one of those cylinders. That being the case, I can derive the diameter. Why do I care about the diameter? What if that's the right thickness and a little sandpaper and some patience makes it easier than rolling tube after tube after tube after tube? Or, if I don't like that, what if that diameter equals this evergreen tubing, which is intended to fix my Viking lander later? That comes under work smart, not hard. And those of us with significant amounts of experience find it annoying to roll little tubes. So, you know, it's worth a thought, and you know, we'll pause and work some of those numbers out. The next step in this would be to score any place where you're going to bend. I would, on a cylinder, I want to score the ends because they're going to fold back and hold parts. I am not going to score the flap because that will make it into a teardrop. The flap helps to keep it round. There's some tricks about making a cylinder so that that all disappears. Not this time. So, there we go. This needs to be scored. These need to be scored. Then we're going to cut them and fold them. So the intent is, while our more simplified stuff is curing, to bring these to life. Here's Julius's paper replica pattern. We're going to make the bogies for it. We'll focus on the bogies and then wheels separate and distinct. So off screen I have the images that are on paper replica blown up so I can actually read them. And the part numbers are referenced. The pivots that actually hold the wheels are number 50. So I got 150, 250, 350, 450. Those are the ends. There should be a 51 here. And its matching number is a 51. So there's 151, there's 251. These pieces here are all part, they're the knuckles that hold the wheels. 50, 50, 50, 50, 51. Okay, so now we have the knuckles that hold the wheels. And then we have the tubes. I'm going to riff on tubes. There's a lot here. 40. 40, 44, 45, they're twinned. 42 is the other tube. 42. 42. 42, of course, being the answer to life, the universe, and everything. Now, this is all wheels. The wheels will wait. This is a typical score and go problem. It's also a small cylinder problem. I am not a mathematician. I do know some dumb stuff. Circle calculations can be accurately done by simply going on the internet and finding a calculator that works well for you. What if I wanted to substitute these for dowel, or for straws, or for evergreen styrene tubing? Sure would simplify the build. So, Mr. Pointer, there is a relationship between the circumference of a circle and the diameter and the radius. Pi r squared. No, they're not the round. If I measure from here to here, I know the circumference of a circle. I know that has to be the circumference because it's expected that this edge will mate to this edge of every one of those cylinders. That being the case, I can derive the diameter. Why do I care about the diameter? What if that's the right thickness and a little sandpaper and some patience makes it easier than rolling tube after tube after tube after tube? Or, if I don't like that, what if that diameter equals this evergreen tubing, which is intended to fix my Viking lander later? That comes under work smart, not hard. And those of us with significant amounts of experience find it annoying to roll little tubes. So, you know, it's worth a thought, and you know, we'll pause and work some of those numbers out. The next step in this would be to score any place where you're going to bend. On a cylinder, I want to score the ends because they're going to fold back and hold parts. I am not going to score the flap because that will make it into a teardrop. The flap helps to keep it round. There's some tricks about making a cylinder so that that all disappears. Not this time. So, there we go. This needs to be scored. These need to be scored. Then we're going to cut them and fold them. So the intent is, while our more simplified stuff is curing, to bring these to life. I'm going to stop and sum up here. I want to wrap this video up. The shooting that I've done later is longer and a little bit more focused. So we'll do a quick wrap up and do a look ahead. We've been working on John Jay's 124 Curiosity rover and Julius Pradana's 120 Curiosity rover, Julius is being the more detailed of the two. The focus so far in this build has been the construction of the bogies, the articulated wheels for the rover. John Jay's less detailed version thereof I now have complete, and this is what we're seeing. The single layer wheels, the pins in the center have all been dabbed with, merry-go-round. The pins in the center have all been dabbed with gray paint to try to make them a little closer on theme. And despite the gleam, so has the pin at the joint. There's the layered wheels, which do move. It looks like I didn't color the edges of a couple of them. Turns out there's any number of different sizes of soda straw. Well, I found one that fits. And these parts have a cardboard backer in them. So it's not just a tube stuck to this flat surface. I referred to paint over and over again as I was building this. Didn't paint them. I took the magic marker and went nuts. Here in this view, you can see I took pattern number 2. I cut the ends off of the bogey, flipped them, glued them down to give me strength for the articulation joint. This one's stiffer than the other, but it does move. As to look ahead, this is the progress on Julius's kit. Looks an awful lot like that picture. As I build the later wheels, I get a little less consistent. I regard this effort as a bit of a plastico. So I did not beat myself up about the lapses in detail. I'll go through the process of specifically how I did a wheel and how I stuck them together. I will teach the art of making tubes. There's 2 ways to make a tube. One, you flatten the seam so that it nearly disappears. If I'd have thought, I'd have taken an example to hand where I could demonstrate one. The other is to just wrap it round and accept the fact that it's going to have a joint. When you wrap it round and accept the fact it's going to have a joint, it come out something like this. In this case, that can disappear, assuming that the contours on the ends allow it. A good model maker would put that seam on the bottom. I think Julius is a really good model maker. The sticks are another, merry-go-round there. The sticks are another attempt at putting structure inside those struts so that when they're put together, they are easier to bond. If I have an end to glue to, regardless whether it's actually glued to the inside of the tube or not, I have a surface. And if it's the right length, I can do it on both ends. It gives a little more rigidity, a little bit more strength to the structure. I had a kick out of this. I didn't really show it. John apparently was one for visual jokes. In the 12 scale kit, I think there's additional Easter eggs. I don't think I'm going to put this on my kit. If I choose to do a base or something, I'll put it on the base. This is something that any paper modeler should expect. An indication of what a mountain fold is, mountain being up, valley being down, and the symbology for it. And John Jay has actually added the roll. And that's, you can find that throughout his kit. A little bit of look ahead. It's John's chassis. John Jay's chassis. Really nice. JPL logo, the mission patch. I don't know if that's on the real vehicle or not. I'd have to do some real looking. Square, clean, beautifully put together. I felt the need for additional rigidity. You can see me squeezing and it's not moving. Reason being, I've included an interior structure. And when we actually shoot the construction of this, I will do this on Julius's kit and demonstrate this, because I have a feeling I'll be gluing this shut just to satisfy myself long before that. There is a structure inside which allows, I don't know how easy this is going to be. I don't think I'll fight with it. But anyway, there's a structure inside which allows a channel here, but supports I have 2 V's of cardboard carefully set to depth so that there's room for the axle, plenty of rigidity. I haven't stuck the axle in yet. This is the radiothermal generator. I'm not really clear whether the actual item is square like this or whether those are radiator fins around it. RTG being a core of plutonium which heats up in a controlled way, causing a difference of potential. So the exterior is radiator after radiator to help it stay at a controlled temperature and provide power as long as possible. This is that marvelous wigwag part of the bogies. Kind of a shock absorber, I would guess. I laminated that and painted it. Paint again being marker. A little bit of gray paint will go on the ends when I'm more clear about how it goes together. I'll focus on Julius's rocker and show how it's constructed. So with that, adios, and we'll pick it up the next time with a detailed look at how I actually accomplish what I just showed off.